giving it to him.
I hear you. Right. Well, good afternoon, everyone. Our goal today is to finish off the work and to give you a little intro to the final exam. So we're going to look at hypothesis testing for the difference between God, it takes forever to write this heading down. For the difference between two means. It is very similar to hypothesis testing for the difference between two proportions. So there's a fair amount of kind of logic overlap. So I'm going to give you a story, and we're going to go through one of these questions, these hypothesis tests, as much as I can by hand, and show you how you would go through it, and hopefully you'll see many of the similarities between that and what you would typically do in the proportion version of this. And then once I've done that, we'll go and look at the homework questions. I'm making an assumption here. We haven't done any of this yet because I've done it all with my other class. Did we finish last time on just single mean hypothesis test? Right, so okay, so I'm not duplicating. So here's my little story. I'm going to have males, and my other population is going to be females. And we're interested if there's a difference in height. So mu1 and mu2. So I'll write them down. Mu1, you pronounce it mu1, right? That's the population mean. Well, for, in this case, males. And mu2, you drew it out like that, is the population mean for females. And we are interested in setting up a hypothesis test to see whether males are taller than females. I think that's an earth-shattering thing, but let's see if we can prove it. So to do that, we are going to have to set up a hypothesis. We're also going to have to collect data. So let's imagine we start thinking about collecting the data. What I would do is I take a sample, say 100 people, and I found that the average height of males is 57 inches, and that the standard deviation of my sample was 5 inches. And then my second sample would be, say, 150 females. And the average height of the females was 56, and that the standard deviation was 2. And connected to this story, you always have to have a thing called the significance level. And it's almost always, at least in this textbook, 5%. But it is allowed to be 1% and also 10%. But they seem to only do 5% in this textbook, so that is fine. So that's basically the information, the two samples. So how do we set up the hypothesis test? Well, you have a null hypothesis and you have an alternate. And the null hypothesis is always that the difference between the two is 0. So in a way, there is no difference, right? Males and females are on average the same height. Now the alternate is mu1 take away mu2. Now in my story, although I haven't written it down here, didn't I say we're looking for evidence that males are taller than females? So what would the alternate be if I wanted to prove males were bigger, taller than females?
Greater than.
Agreed? Greater than. If I wanted to prove that males were uglier than females, I guess it would be less than. If I wanted to prove that they were just different, wouldn't we use the not equals to? So there are 3 versions of the alternate. This one is the right one, but let me show you the other 2 that can happen in different stories. Sometimes you want to prove that the first one is smaller than the second, and that looks like that, right? And sometimes you want to prove that they're just different. Isn't that very like P1 take away P2 greater than 0, P1 take away P2 less than 0, and P1 take away P2 not equal to 0? Isn't that very, very similar, right? What name do we give to this one? We call this right-tailed test, left-tailed test, and two-tailed test. Because from time to time, aren't the questions like what kind of test this is, and you say left-tailed or right-tailed or both-tailed, two-tailed. All I'm going to do now is rewrite the null and alternate. So the null is always going to be that the difference is 0, and the alternate depends on the story is one of these 3. And we've already decided that in this story, we're trying to prove that males are taller than females. So that's my alternate. And I'll call that step 1. Now, step 2, you're going to calculate the standard error. And it's the standard error of the difference between the 2. And it's going to be written like this. And there is a formula for calculating the standard error for the difference in 2 means. We have seen this formula when we did confidence intervals. So that was a fair amount of time back. Can anybody kind of thinking of what happened on Wednesday, what that formula might look like? Here's a clue for you. It's some fraction plus another fraction. Any takers? What would the formula be?
Is it X R1 times?
No.
No.
I know where you're going, or I think I know where you're going. That sounds very much like you're going to do a population one.
Is it S over N?
Closer. It's this guy. When there are 2 of them, it's that. Now, if there was one of them, at least you'd be bang right. It'd be S over N, S over the square root of N. But when you do a difference of 2, it's that. If you go back and look at your notes for a 95% confidence interval for the difference between 2 means, you will find this is the formula for the standard error, right? So it's the same formula being used this time. Now, we're now going to calculate a guy called t-score. Oops, too many. There we are. The t-score. And the formula for this guy is x1 take away x2 over the standard error. Isn't this very like P1 hat take away P2 hat over the standard error, right? So that's very similar. And in this case, it's a t-score. And I should have, and I forgot to, but I'm going to do it now, is I should have started putting some numbers in. So this guy is 57. Take away this guy is 56. And this fella here, I'll do it on the calculator. This guy here is the square root of S1 squared, which is 5, so 5 squared, divided by 100, plus S2, which is 2 squared, divided by 150. And the answer I got is that this guy is 0.526. So 0.526. And then I'm going to deliberately do a mistake here for this calculation. 57 take away 56 divided by 0.526. would you agree that that is a very strange looking t-score? Because t-scores and z-scores tend to have the same kind of numerical values. What did I do wrong in that calculation? What should I do to fix it?
You
need parentheses on the 57 minus 56.
Okay, so here we go. And now we got 1.90. Okay, let me pause here. Are you comfortable about how you can take a story and create the null alternate hypothesis? You feel you know how where that came from? Are you happy about using this formula for the standard error and then this formula for the t-score? Okay, so we can now move on. Basically, that's step 3. We can now move on to step 4, where we calculate what's called the p-value. And the p-value is the probability that you get a t-score bigger than 1.9 or less than 1.9, because you have to make sure you get it the right way around. Okay, agreed? Now, that I can't do on my calculator. So I'm now going to move over and hit a salt button, and hopefully hit a salt button anyway. I'm sure where this thing's going. Oh, shooting space. Where are you?
Why is it smaller than 1.9?
Oh, it's smaller because smaller. I'm agreeing with you. It should be bigger, shouldn't it? Because of that. Right.
Oh, that makes more sense.
Right. I'm too busy thinking of the next step, and the next step is me trying to figure out how to bloody get these windows to close so I can show you the window I would do on. Right. There we go. So I'm going to nip over and find the probability that a t-score is bigger than 1.9, which is the correct order for this one. Here we go. Make sure that if it's only a p-value that you're interested in, that you do distribution calculations. See that guy there? Now, click on this and do t-distribution. Oops. Yeah, I was right. I just talked myself out of it. Now, we're going to have to do degrees of freedom. There was in my story 100 people in the first group and 150 in the second group. So the degrees of freedom are 250, take away 1. So that's 249. The degrees of freedom, thankfully, are not a problem you need to be too concerned about because they don't happen that much. And one of the problems is that there is more than one way to get degrees of freedom when it's 2 means. When it's 1 mean, it's dead easy. It's a sample size take away 1, right? That's it. But when it's 2 means, you add the 2 sample sizes and subtract 1, which is what I'm doing. And that's accepted. But I said there's more than that. There are some textbooks where you subtract 2, 1 from each. So in that case, the answer would be 248. There are other textbooks that say you pick the smaller of the 2, in this case 100, and take 1 away from that, so it would be 99. If you go and look at the ebook, there is a ridiculously ugly formula that you can go finding if you really want to, and it tells you how to get the degrees of freedom doing that. The bottom line is the numbers are going to be so similar to each other that when you round them off, they end up being the same answer. So it's not going to actually be that big a deal, right? So if I put in 99 instead of 149 or instead of 249, when I round off the answer to 2 decimal places, it's going to look exactly the same, right? At least to 2. So we got this guy, and we want greater than. Which one of these dots do you pick for a greater than?
Right tail?
And then I go here and I make it greater than, and the number we had was 1.9. And can you see this guy at the bottom? That's the p-value. So to 2 decimal places, that's 0.03. That just show you why it doesn't make so huge a difference. Can we just pretend that it was 200? Right. 200. Do you see any difference in that answer? Not anything significant. Suppose it was 99 then. Do you see any, well, I have to change this one a little bit. There we go. Do you see it's still 0.03? So in a test situation, it's not going to be that bad if you can say, oh God, how do you get the degrees of freedom? Is that you take 1 away, or do you add them and take 2 away, or, you know, whatever. Can you see that it's probably not going to make any real difference? The numbers when you round them off are the same. So we are now returning back to this question. And there's the guy I got, right? 0.03. And then we do this fella. We do the test. Is that significant? Is it so small that it's interesting? Well, is the p-value less than that guy? I hope you'd all say yes, it is. Right? And then don't you have one of those weird lawyer-esque sentences? You can say it a couple of ways. One way is we can reject the null hypothesis, right? If you reject the null hypothesis, doesn't that mean the exact same thing as the alternate is true? Or you could say in English, we have proved that men are taller than women. Right? So they don't always phrase it the same way, but if you look at the choices of the 4 sentences, won't one of them look something like this sentence or like that sentence, and you would pick the one, whichever way they decide to phrase it. Would you agree there's a lot of similarities in how you do this compared to the difference in 2 proportions? You see there are a lot of structural similarities, right? This formula is a little bit different, but isn't the t-score very similar? Once you get the t-score, isn't the p-value the same calculation? Isn't the conclusion the same? Isn't this the same, right? So if you know how to do proportions, you are pretty good at doing any of them. So I'm now going to go and look at the homework questions. And with a bit of luck, I'm going to do the homework questions. Why can't I see the guy I want? There we go. Are you looking at hypothesis tests of the difference in 2? Okay. Now, there are a whole load of questions at the beginning that are all to do with pick the answers, and I want to skip by them right now.
The key is on.
Oh, that is annoying. Thank you. Forgot about that. We don't really want to see the key. It's a distraction. Right. So I want to just get to those questions where we do the hypothesis test, right? And we'll start with this one then. Now, I could probably make this a little bit bigger, can I? Let's see if I can make it bigger. There we go. Oh God, this is a pain. A set of body temperatures was taken on 100 adults. 47 of them were female and 53 were male. This here is a printout. So basically this is kind of what you would see in SALT, or at least similar to it. And we are going to take this information and we are going to create a hypothesis test, find the t-value, calculate this fella, find the p-value, and then make a conclusion. So start at the beginning. We are trying to see, is there any evidence to what do we want to do? One are females, make sure I get that right. Females against males. So the null hypothesis is mu1 take away mu2 is equal to 0. So hit the Greek letter and pick that guy. Does anybody remember from Wednesday how you get that annoying little subscript? Because that's what it needs. Which one of these buttons do I find the subscript in? Okay, and there it is there. So there's your mu1 bracket, space I should say, take away, Greek letter, mu, subscript 2. Move the cursor, equals 0. Pretty much, if it's a difference between two means, wouldn't that always be the null hypothesis? So you don't need to think about it, it's the same answer all the time. Now, in this story here, they're kind of vague. I don't know if I'm trying to prove that females are bigger than males, females are less than males, or that they're just different. So I'll read it one more time in case I missed it. A set of body temperatures was taken of 100 adults. The Minitab output is shown below. 1 is females, 2 is males. Got it. Since they are not mentioning, is there evidence to prove from this set of data that they're bigger than or less than? I'm just going to assume that they meet not equal to. And that seems to work. I think they could have been more helpful and say, look, is there enough evidence to prove they're different, right? It would have been nice if they stuck that sentence in. Or that females are bigger than males, or that females are less than males, right? Something that tells me what to do. So work on the assumption, if there's no clues, that you're just trying to test that they're different, right? Not equal. Now, what is the value of the test statistic? Well, if you look at that guy there, here he is. Right? I didn't need to calculate it. Okay. Now, this thing here are the numbers that you would use to get the t statistic. So, wouldn't it be x1 bar, which is that guy, take away x2 bar, that guy. So I click on this one, and what do I want? I want the 98 one. So here are the females, here are the males. This box here would be the standard deviation of the female, so 0.657.
Can I ask a question?
Yes.
Why does it have the -0 there?
It's not necessary, because isn't -0 doesn't change anything, right? I suspect the reason that they're putting it in is more like a lawyer. We are only looking at differences being equal to each other, right? So that makes 0. You could set up a more advanced hypothesis test where you're trying to prove that the difference between them was a number like 10. Like there's at least 10 inches difference between the two. If that did happen, then this 0 would become 10. Now we're not doing that, so we can pretty much ignore it. Now, the other guy, I believe, is the 0.7 version, right? And the whole answer ends up being 2.76. Are you comfortable about how you fill these numbers in? Now, what is the p-value? Well, that's in here somewhere if I can find it. There we go. Right, let's look at that guy. Is that guy less than 0. Excuse me. Is that guy less than 0.05? Yeah. And so the population mean body temperatures are greater, the same, or less. Oh, the little buggers. It's greater for females. The probability of the observed difference is less than that number. Where are we going with this? For me, it could be the the observed difference. What is the observed difference? The observed difference is those two. Okay, 11 to 67. That's not there. What the heck am I doing? I'm trying to find this number and I can't find it. What am I missing? It says the probability greater for female compared to male. The probability of the observed difference in samples this size is the p-value. Well, it's 2.76, but that's not there. Okay, let's figure out what my brain is not telling me. Okay, where did this 0.393 that they're talking about come from? Oh, shoot, there's the difference there. They're talking about the difference, they're not talking about the p-value directly. And the difference is somewhere between 0.39 and minus 0.39. Why is there two values? Because couldn't it be, if you did it one way around, it'd be positive, and if you did the other way around, it was negative. What an annoying question. And just to finish with then, so if you're wondering where the 0.393 came from, it came from here, that one. And they're asking, what is the difference between the two? And the difference between them is bigger than that or less than that would be significant. And it says, does this require any action? Which is kind of weird, but no actions are required. All we're doing is testing it. We're just saying whether it is not. So let me invent a question where that might actually be useful. Suppose you did a hypothesis test and you managed to prove that the new drug was better at doing the job than the old drug, right? Can you imagine that? Then wouldn't your decision be start using the new drug, right? You'd actually do something about the answer. If I find out women are taller than men, I guess that's the end of the line, isn't it? It's not like men need to go in and get an operation where we break some bones and make them taller, right? You're not going to do anything about it. You're just going to say, okay, that's what it is. Right, now, that guy that we just did here, and this question directly after it is essentially the same question with different numbers. So hopefully if you go through this one the same way we did that one, and when you do this one, oh, just to be different, they don't have that really weird sentence that I had here. Okay, let's do a real start to finish thing. What you're looking at here is a study, represent data, and the response to the question was, what's the fastest you've ever driven? And in this story, we have two populations. Females, there's 103 in the sample, And the fastest that they've ever done was 88.3, and that their standard deviation is 14.3. And then the other group was males, and they were 85 of them, and their average was 107.5, and their standard deviation was 17.2. So I've got all these numbers set up because I know I'm going to use them in a minute. And we are going to do a hypothesis test. And when we're finished, it's either there's enough evidence to reject the null hypothesis or there's not. So here goes. And I don't want to hit that button because I know what happened the last time. Gotcha. I'm going to do inferential statistics. I'm going to go here and do 2 sample T. The first group of people is going to be females. Okay. So for the females, the average is 88.3. The standard deviation is 14.3. And the sample size was 103. Are you comfortable about where those numbers came from in my story? Right, if you go to the second group, which is going to be the males, and the reason I double check that is I've seen some questions where they tell you males and females, and then later on they switch places, right? Males aren't first, they're actually second. So that's annoying when they do that. And 17.2. And that goes there. And 0. And we are trying to find, what are we trying to find? Bigger than or less than? Assuming now the alternate is that it's higher, right?
I think didn't you switch your deviation in your sample size?
Sample
the
size.
second one.
Oh, for that one, yes. If you were, yeah. If you were doing this in a test, will you please write down, and I'll talk about this hopefully later, when you're doing questions involving SOC, I would like you to write down these numbers so I can tell what you typed in. Because see, if you did that mistake I did a few seconds ago, wasn't that just careless? It's not that I don't know how to do it. But if I typed in those numbers, wouldn't I get an answer that was just wrong? And all that WebAssign tells me is that you got it wrong and you got 0 out of 20. That's not much help to either of us, right? So if you show me the numbers, I can say, oh, flipping heck, you just switched those. That's take 2 points off, 18 out of 20, right? So we want to try and give you that chance. So we're trying to prove that males are bigger than females. Now that's a question that if you phrased it the other way would be that. Isn't males bigger than females the same thing as females less than males? So you see, you have to turn it around in your head. Now, I would normally hit generate results, and I will in a few seconds, but I want to tell you about this weird box that we've never need to talk about before. It says assume equal variance. Some questions, I know for sure one question in particular, says that you're going to pull the data, right? Pull data, a phrase like that. If you ever see pull data, hit that button. So if the question says, blah, 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 use pull data, make sure that you hit that box there. If you ever get a question, which is less likely, but the 2 standard deviations are very similar, 14.3 and 17.2, would you agree that they're distinctly different? Now, they don't need to be identical, but 14.2 and 14.4 is good enough, right? If that happens, assume equal variance, click that box again. So if it says pull data, or when you look at the 2 standard deviations are almost the same guy, hit it. For the vast majority of questions, we can leave that blank. Now I'll generate the results. Lots of different numbers. And did I go and get that the wrong way around? Nobody noticed my mistake. I just noticed it. There we go. Generate it now. There we go. Can you see that that p-value is really tiny? So when we go to our question, was that tiny value less than 0.05? Yes, it is. So don't you just hit reject the null hypothesis. Now, can you imagine if you're doing your homework and you get 5 guesses, you could just not do anything and hit the wrong button. Okay, it didn't work, you hit the other one. But what's going to happen when you get that question in a test, right? You haven't done all the details that you need. So I want you to try and be honest with yourself, because it's important that you are. So let's do another one of these guys. Do I want this one? Maybe I want this one. Well, I don't have too many choices, so I'm going to have to pick. I'll pick this one. Here is data to do with Pennsylvania and California. And these are elementary statistics classes. And the results, the summary is the number of hours that they slept. So in the Californian sample, 177, they slept about that many hours, standard deviation, this one. See these guys at the end, the 0.13 and the 0.14? Never get used in any question, pretend they're not there. So I'm about to hit the salt button. And I'm going to move this guy. And let's see if I can do this correct. The first one is Californians, and they had an average of 6.94 hours sleep. The standard deviation for the Californians was 1.72. The sample size was 177. You comfortable? That's where those came from. Right, if we do the other group, was the people from Pennsylvania, their average was 7.15. That the standard deviation was 1.96. And that had a sample of 194. Now, although you can't read the question, I can. One is Californians, 2 is Pennsylvanians, that's good. And is there sufficient evidence to conclude that the mean number of hours slept are different? So they're telling me it's different. Okay. Is there enough evidence to prove that they're different? Right, that's what we've got here. So there was no mention of pooled data, and I think they, what the heck is that doing there? There we go, it's 1.72. Right. I don't know, do you think they're close enough to be considered equal? Or do you think they're far enough away to leave it alone? I think they're far enough away, right? So, generate results. Here's the p-value. Does that guy look like it's less than 0.5? And that means then, if I bring this guy over, doesn't that mean that there's not enough evidence? So, fail to reject. Now, there's a whole load of other things going on here, but in this box, for instance, you would be doing mu 1 take away mu 2 equals 0. And we're being asked to prove that they're different. So the alternate would be not equal to, and in this world, not equals to, you stick an exclamation mark. Now, define all parameters. The parameters being used here are the mean number of hours slept. Oh, by the way, isn't this the word parameter they're using? So won't that be the population? Right, so the mean number of hours slept for students at Californian and the mean number of hours at Pennsylvania. Are the necessary conditions are met? Okay, we haven't talked about that, so let's do it. I don't know which ones they mentioned, but here are the basic ones. Shouldn't the data be a fair representation the population. So I would assume that people who take statistics are probably not that different from anybody else at that university. Doesn't the sample have to be big enough? In the context of this, big enough is 30, right? Is there at least 30? And the answer is yes. So yes, they are. Now it says the conditions are met, although the samples are small. I don't know about that. I would probably pick that one, right? They're sufficiently large. This guy is the test statistic, which I already know, and I've calculated it using SALT, so I'm copying it. It goes there. The p-value was in SALT. I'm just copying it and pasting it as well. Would you agree then that this is definitely not less than 0.05? So let's see what this says. In this situation, is a decision leading to an action required? No, there isn't. And there's my fail to reject. Okay, so if you've done one of these, haven't you pretty much done all of them, right? Put in the population one's numbers, put in population two, the samples, and let SALT do the rest. So let's go back to the stuff I skipped at the beginning and see what's going on here. For each of the following research questions, specify whether the parameter of interest is one population mean, the population mean of a paired difference, which we don't know about because we're not doing that, and the difference between two. So residents of a neighborhood have been complaining about speeding cars. The speed limit in their area is 25 miles per hour. The local police monitor this situation by recording the speed of 100 randomly selected cars. And what they want to know is whether the mean speed of all cars that drive through this area is actually too fast, right? Bigger than 25. Now, as far as the population is concerned, isn't this one population mean? How do I know that? Wasn't there only one sample of 100 cars? It wasn't like a sample of 100 from this street and a different sample from a different street, right? It wasn't two separate groups. Right, in this one here, referring to part A, after collecting this data, the police decide to install an electronic roadside sign. You know those ones, there's a few around, aren't they? It tells you too fast, you're doing 60, that thing, right? And I'm assuming that that is effective, at least in some cases. But they want to check that it's effective. So what they do is, after that machine has been installed, they go back and they randomly select another 100 cars. I'm pretty sure it's a different 100, right? And they want to know whether the mean speed is lower after the installation than it was before. Can you see that this story is now going to be the difference between two? 2 months ago, I got 100, I got their speed. I installed the new gizmo. I went back today and I got a different 100 numbers, and I want to hopefully find out that they're reduced. That would have been a really good question for one of those, should any action be taken? Well, if that new sign reduced the speed, I guess the action would be keep it, right? It's doing its job. Just to be perverse, can you imagine that it actually made people go faster? Oh, I'm only doing 30, I could do a bit more, right? Just being perverse. Wouldn't the action be, take that damn thing down? It's making it worse, not better. Suppose the evidence was it didn't make a darn bit of difference. People are still going the same speed, whether that new gizmo was there or not. What would the action be in that case?
Just leave it alone.
That would be a valid action. That's what governments do. It's not working, but we'll keep spending money on it. Or couldn't you also say, and I'm not saying my answer's better, take it away and use it in a street where it did work? Yeah. there are not many of those action required questions, but I wanted to kind of give you an example of what one looked like so you get a feel for, you know, what they're asking. Which one of these formulas do you write down for the difference between two populations? Which one of those 6 dots is the notation for the difference between two populations?
The bottom one.
Bottom one. If it was the difference between two samples, wouldn't it be that one? Wouldn't that be a single samples population? Wouldn't that be a single, a single population? And wouldn't that be a single sample? Right. A plane, or you plan, oh God, that's hard. You plan to fly from New York to Chicago. You can use Delta or American Airlines, right? You could use 2 airlines. You are one of these very pernickety people. You don't like delayed flights because you want to make sure you get there in time because there's a conference, right? Or you're a doctor and you're going to a hospital to do a surgery, right? You don't want to be 4 hours late and there's somebody waiting in a surgery for you, right? So you're being kind of pernickety about it. And you collect data on 25 days worth of both flights, right? The American one and the Delta one. Isn't it that guy that represents the difference between the two? And then the sentence that basically says that. This one is pretty much the same kind of stories, right? Here's one that involves using salt.
Hey, Professor,
Yes.
I put in mu1 minus mu2 for part B, and it says that it is incorrect.
That this one is?
No, part B.
Oh, this one here? Okay, let me read the story then. After collecting the data described in part A, the police decide to install, is that the one?
No, what question are you on? I was on
Alright.
question 2.
Oh, question 2. Let me go back to that one.
Yeah.
You put that one in?
Yep, and it said it's incorrect.
Let me read it in case I misread it. You plan to fly to New York to Chicago, choice of 2 flights. I got that right. Some of them are delayed. Yeah, I got that right. You have data for both flights. Yeah. You want to know whether one flight has a higher average than the other. Yeah. That we used for the population parameter of interest. The only answer that they could be using is that one. Try that one.
That
What
word.
about,
Right. I wouldn't give you a question with that guy because we haven't done it, but that one kind of sneaked in. If you're interested, what's the difference? This is 2 separate populations. This is called a paired difference. So I'm assuming, and I don't know why they would do that, but can you imagine day 1, you looked at the average delay time in both flights, and then day 2, you subtracted them, and day 3. That would be what we call a matched pair, right? An example of data that would look like that. Imagine you were interested in the difference in the ages between husbands and wives. Couldn't you get husbands and wives and have the man's age take away the woman's age? In other words, you end up with just the difference. And that would be the data that you would collect. So I apologize for that one, but everybody just remember to put that one in and you'll be fine. So I guess I should check this one in case they've sprung another one on us, but I doubt it. If they do spring another one on us, it'll be that one, but I'm confident that we're good. Right, we've got about 2 more questions and then I can start talking about this final. We have a null hypothesis and we have some choices. And it says in each of the following situations, determine whether the alternate hypothesis is that one, or that one, right? Bigger than, less than, or not equal to. You actually don't need the salt button. I can do this without this. The null is obvious. Do you notice that that t-score is negative and then that p-value is very small? Which one of those 3 gives you a negative t-score and at the same time a small p-value. One of those three, and only one of those three would do that.
Less than?
Correct. That's it. Now, this one has a positive t-score, but a really big p-value. So what situation would give you a positive t number, but a very big p-value? Now, see if that p-value was tiny like this one, that positive big one, wouldn't you pick that guy? But this p-value is almost like the exact opposite of what it should be, right? If that was the right direction. So I'm using that as, oh, you went the wrong way. So that one's a bit sneakier. I'm going to kind of skip by this one. Do you see that you've got all the numbers you need to get the t-score? Right, we did that by hand. Wouldn't you take that number, subtract that number, and wouldn't you use these two guys here and these two guys here to get the standard error? So won't your answer be x1 bar take away x2 bar divided by the standard error? In this case here, they're telling you the difference. So it's 48, and you're going to divide it by the standard error. In this one, you're going to have to calculate the difference. So it's going to be 39 take away, what's the other number, 36. And then you're going to have to divide it by the standard error. But you're going to have to get your calculator and write down that big formula, you know, S1, square root S1 squared, and you would get it. In this question here, there is all the information that you need in these 6 numbers here. Can't you get the t-score? And the t-score will be 80.57, the first main. Take away 78.54, the second one, divided by the standard error. And to get the standard error, you're going to use that guy is N1, that guy is S1, that guy is N2, that guy is S2, and you do the big ugly formula again. And that's it. Do you want me to do this question, or is it okay me just talking that through? Are we good with that? Okay. Well, I have about 20 minutes to give you a kind of heads up on your final. And the first thing I'm going to do, because I'm sure you're probably wanting to know this, is what do I need to get in the final to pass, for example, right? What do I need for a 2.0? What do I need for a 3.0? What do I need for a 4.0? So this is how you're going to do it. Let's pretend that you looked at your report and it was 91%, just for argument's sake. Take your 91 and multiply it by 7. Not 91%, but just 91. Well, 91 times 7. And the answer you are going to get is, in this case, 637. Now, for you, it's 92%. For somebody else, it's 81%, right? Whatever it is, times it by 7. This guy here is your raw data. It's actually what you got out of the 700 points. Now, I'll write that guy at the side so I can keep track of him. There he is. To pass this class, you need a 2.0. A 2.0 is 750 points. So all you do is you say, okay, that's my raw score. What more do I need to get that? So just subtract them. And I believe the answer is 113. So you need to get 113 out of the 300 points that the final is worth. Do you see how you get what I need to pass it? Now, you might think, nah, I'm going to pass. I want a 3.0. What would that be? Well, you need 850 points for a 3.0. There's the number I've got. That's the one I want to get. That is 213 out of 300. That's about what, 71% in the final, roughly. And some of you, your goal is to get a 4.0. And a 4.0 is 950 points. And if you compare these, if you were that person, need to get 313. Can you see that ain't going to happen? That person cannot get a 4.0. So far, so good. Are you comfortable? You can take your percentage score, multiply it by 7 to get your raw score, and then use these 3 numbers to figure out what you need. Now, every 10 points that you get more than the score is 0.1 in your grade. So for instance, suppose you got 233, that would be 3.2. If you got 153, that would be a 2.4. So you can actually calculate, almost to the decimal point what your grade would be once you know what your final score is. Any questions so far?
Yes, I have one.
Go for it. What you got?
So if you don't pass the final, do you pass the class or do you have to like retake it?
If you do, you don't need to pass or fail any of the bits. You just need to make sure that your total passes.
Okay.
Right. So I'll give you an example. You might get 130 points in the final, which is definitely failing the final, right? But couldn't you, if you were this person, wouldn't you still pass the exam because you get about 2.2 as your grade? That makes sense? Right.
Yes.
Right.
Thank
So
you.
what I'm going to try and do, if I can find the darn thing, which is not actually that obvious to do. Tell you what, give me a few seconds. I'm going to close every window in sight, because that's part of my problem. I've got too many windows, I can't find anything. And that'll give me a chance to show you what's in Canvas, which is where I want to go next. Does anybody know what day our final is? Because that's the first time we're going to talk about.
Friday.
In 1 week.
In 1 week, okay, that sounds right. Oh, come on, darn and spite. Have you noticed I'm not swearing? You notice that? You see how good my self-control is? I closed so many windows, I can't find the window I need to close because there's another bloody window in front of the window that I want to see. And I think I found the window I want to see. No. Okay.
Isn't saying bloody cursing from across the pond?
Yeah, but it's a very mild form of cursing, so I can get away with it. I don't think that would offend anyone, right? Considering the kind of language I could have used, I don't think saying oh, bloody this or bloody that is it's a very English thing to say, actually. I can't close this window. I'm trying to find a bloody little tiny window this size that I need to close so I can open the window I'm trying to show you. Otherwise, I'm just going to tell you what I see because I can't do it any other way. Right, open window. Where are you hiding?
How many questions are on the
Got
final?
it. Oh, well, I found the thing I want, so I will talk to you now. There is going to be 2 parts to your final. Oh, I'm not good at multitasking. I should stop multitasking. It ain't my thing. Right. I bet you I'm going to lose that little window now that I've did this. Okay. Are you looking at our syllabus? Right. Now, your question was how many questions are in the final? They're going to be in 2 parts. The first part is going to be in Canvas. I'm going to write down 20 multiple choice questions. So all the multiple choice, you know, the ones where they give you sentences at 1, 2, 3, 4, all of them are going to be in Canvas. And the reason I'm doing that is I don't like WebAssign, because have you ever got a question where it's maybe the third one, but it could be the second one, and you'll always pick the wrong one? I'm writing questions, so there will be one definitely right answer and nothing else, right? So that'll make my life and hopefully yours a little bit easier. Now, if we look at this here, Friday, 1 till 4. That's when your final is going to be. Friday, 1 to 4. If Friday doesn't work for you, you got to tell me about it and we'll see if we can put it in another time. But probably for most of you, you would want the extra days. Monday is a class day. So Monday, you're going to turn up, those who want to at least, and ask me for help. I've forgotten how to do confidence intervals. Can you show me? That kind of question, right? Now, if you look at this list, here is the content for your final. It's everything that you see from what we did way back in week 1, which was chapter 2. And the last thing we're going to do is hypothesis testing. Now, I have some help, I hope, some things that will help you. Can never find things when I want them. Should be. Okay, I will go looking for it. There is a practice final, so you can have a look at it. I know it's around there somewhere, but the faster I go, the more mistakes I make. What that is just to give you an idea of what the questions are going to look like. So let me show you your test. On Canvas, you're going to get section 1. And section 1 is going to be 20 multiple choice questions, and they're all worth 5 points. So that's 100 points. In WebAssign, you're going to get the final exam questions, and there's 10 of those, and they're worth basically 20 points each. So that's where the other 200 points go. Now, the WebAssign are either questions that you're going to use SALT in. And if you do use SALT, will you remember to write down all the numbers that you put in? Or you're going to get questions that you have to use your calculator. You know, the kind of thing where we tell you all the stuff and they say, find the t-square, right? In which case you're going to show me working. The Canvas questions, all I will get from you is that question 1 was A, and question 2 was A, and question 3 was C, and question 4 was D, right? I will not be looking for any working. There's no point in showing me working. If you do have to do calculations, that's fine, but don't photocopy them, don't show me. Because multiple choice, it's the right answer you picked or not. So you get what you get. On the other hand, section 2, right, these guys, I do want to see as much working as possible. So can you imagine this is like a miniature version of what I would get uploaded into Canvas? You'd have question 1 was A, and question 2 was B, and question 3 was C, and question 20 was D, right? It would look like that. And then you would have your answer to question 1 where you'd write down all the working. And then maybe on the next page for question 2, you would tell me what you wrote into SALT, and then you'd get your answer right, if you had anything. And you'd finish with question 10, and you'd show me your working. So when you're finished, what I get is a copy of all the answers to the multiple choice and every piece of working you can possibly think of for the section 2 stuff, right? The WebAssign stuff. And the second chunk is going to be really important because that's how I can give you partial credit. I've been looking at, you know, the tests, and I'm not able to give you many points because all I know is that the answer was 7.5 and that it's wrong. I have no idea because you use salt, and I understand why you got 7.5. If you show me the numbers that you put in, right, then I can see, didn't I do one where I got all the numbers back to front and upside down? At least if I saw that, I would say, oh, he's putting that in there and you should have put it over here. Yeah, the person knows how to do it. They were just a bit careless, right? In which case I can give you partial credit. Any questions right now? Okay. Your test, your final exam is going to be chronological. So see section 1. The first questions will be from week 1, that's chapter 2 stuff. And the last question you're going to see was from this week, right, chapter 13 stuff. The same thing is going to be true about the final exam. The first question you're going to get is from week 1, 2. The last questions you're going to see are from this week. Half the things that you're going to study for will not even appear in the final exam. But you have to assume that anything could happen. So you have to be really prepared. Because you know, if you only study for half of it, isn't that the half that isn't in the final? That's Murphy's Law. So be prepared and you'll be fine. There won't be any great shocks. I hope putting the multiple choice in Canvas is going to reduce the stress in the sense that, yeah, there's only one right answer and it's pretty obvious who it is, rather than, because some of the ways they phrase those questions are ridiculously weird and I don't think it's fair. So that's my motivation. Yeah, there'll be some questions that you do calculations here, but if the answer is 4.5, one of the 4 answers will be 4.5, right? So it'll be pretty obvious what it is. Okay, another little pause. Any questions? Let me put a negative on this. Most people, not everyone, do worse in the finals than they do in the tests. A test is 3 weeks work, a final is 11 weeks work. Try your best to get the best notes that you can, because you are allowed to use your notes. Write down things like the definition of terms, because, for instance, in multiple choice, I'll give you a story because it's actually in the practice final. I just can't find it right now. A person wants to know the opinion of doctors in hospitals in America. And the way that they collected the data on their opinions of hospital services is that they randomly picked 3 hospitals in America. And then they asked every single doctor at those 3 hospitals what their opinion was. And the multiple choice question was, what kind of sample do you call that process? What kind of sample are we going? Does anybody know what kind of sample you would pick 3 people, or 3 in this case hospitals, and ask everyone at those 3?
To the convenience sample?
I know, no, but it sounds like it. It does, because it's easy to do, but no, it's called a cluster sample. Don't know if, I'm sure you've heard that term because I did do it. But you see, that is the kind of piece of information that you've forgotten about because it was 8-9 weeks ago that we even went there. And so when you start doing your revising, I suggest strongly that you maybe organize your notes in an easy to find form. Maybe put everything in chapter 2 on one group of pages, and chapter 3 and chapter 5, to make it easier to find. You can't use your notes for everything, because if you did, you'd never finish the test in time. So it's there for the times that you need to do a quick look. I definitely put every formula that you've ever used probably in one page, right? Easy to get to. Right. For instance, if I said, what is the formula for the standard error of x1 bar, take away x2 bar? Any volunteers now? Because we did it today.
The square root of s1 squared over n1 plus s2 squared over n2.
What is the standard error for the difference in two proportions?
Rick.
Anyone?
It's p1 hat times 1 minus p1 hat over n1 plus p2 hat 1 minus p2 hat over n2.
Now, if you were doing a question where you had to find the standard error, if you don't know what the formula is, isn't that question dead in the water? Now, if you happen to have memorized some of the formula, that really speeds things up. But if you've not got a good memory or it's a while, you might want to think about, you know, spending some time getting your notes organized and getting things that you are probably going to need easy to find. When the final happens, everything's going to disappear. You won't be able to find anything on WebAssign except the final exam 10 questions. On Canvas, the only thing that will be left will be the multiple choice questions, a link to the Zoom so we can all see you, and the place where you will upload all your working. So all the help and all the notes and all the stuff, all the videos will be gone, and all the stuff in WebAssign will be gone. So don't get a shock, right? You already know that's the way it's going to be. So you can only use what you've got. So hopefully you've got some stuff that you can use, right?